Hi guys, I put together a video to help us with these velocity and acceleration problems. So just kind of go through a couple things. Reviewing velocity is distance divided by time. We show that by v equals d divided by t. And we can use this little triangle method. We can draw the triangle and put velocity down in this left corner, distance on top, and time over here. And then we would cover up whichever variable it is we're wanting to solve for. So we want to solve for velocity, cover it up, and then take distance divided by time. We want to solve for distance, you'd cover it up, take velocity times time. Or if we want to solve for time, you can cover it up and say distance divided by velocity. A couple other reminders that are going to be helpful is every hour is equal to 60 minutes, and minutes are equal to, or 1 minute is equal to 60 seconds. Alright, so today I had you guys pick up a velocity math skills handout. So we're going to walk through a few of the questions together from both the velocity section and the acceleration section. So I've decided to focus on one variable for each of these different examples. So we'll start with the velocity problems. You've got some examples that are already pre-printed on the handout for you, but I want to go ahead and do the first question on each section, and then you guys have the other question to do, and then 4 practice problems. So practice question number 1. Suppose polar bear is running on land instead of swimming. If the polar bear runs at a speed of about 8.3 meters per second, how far will it travel in 10 hours? Alright, so we're going to write down our equations. So velocity is equal to distance divided by time. And we're looking for the variable distance. So I need to use a little algebra here, multiply both sides by t. That'll get d by itself. Or we can look back to that triangle and say, oh, I want this variable, cover it up, and you can figure out which one it is more easily. Alright, so our givens, listing those out. Velocity is 8.3 meters per second, which we get from the problem, and our time is 10 hours. However, our units for the velocity are in meters per second, so we're going to have to do a little conversion. So we're going to take that 10 hours and we're going to convert it to seconds. So to convert from hours to minutes, we would take and multiply by 60, and that's going to cancel my hours. I'm going to multiply by 60 again, that'll cancel my minutes, and I'll be left with seconds. Alright, so continuing on then, we can just plug these values into our equation. The distance is equal to velocity times time. So 8.3 meters per second times 36,000 seconds. It's going to give us our answer of 298,800 meters. So there's problem number 1. Alright, next we're going to skip over to practice problem number 3. Here we've got various types of tree sloths share the honor of being the slowest moving mammals. An average tree sloth moves at a speed of 0.743 meters per second. How long does it take a sloth moving at this speed to travel 22.3 meters? So again, I'm going to list out my knowns and unknowns. So I'm given the velocity is 0.743 meters per second, and my distance is 22.3 meters, and my unknown is time. In this problem, the units do agree, so I'm already in meters, so I don't have to change anything there, so that's nice. Alright, I'm going to go with my equation here. Velocity equals distance divided by time, but it's time that I'm going to be solving for, so I'm going to rearrange my equation, or look back to my triangle, and I'm covering up the time, which would end up having me take distance divided by velocity. Alright, so I'm going to take my given values then and plug them into my equation. So 22.3 meters divided by 0.743 meters per second. And that leads me, or results in 30.0 seconds. All right, skipping over to practice question number 5. We've got a cheetah, which is the fastest of land animals. It can run 274 meters in 8.65 seconds at its top speed. And what is the cheetah's top speed then? So listing out my givens, my distance is 474 meters. My unknown is velocity in meters per second. And then my other given was 8.65 seconds. So on this one, I'm using my standard equation, velocity equals distance divided by time. So I just plug in my values, make sure my units agree, which here they're fine because I'm taking meters divided by seconds. And I get 31.7 meters per second. All right, moving over to the acceleration math skills. Acceleration is equal to final velocity minus initial velocity divided by time. We can also put final velocity minus initial velocity together and say delta v. And this triangle just is a Greek letter. It's delta, which means change. And it's the same as saying, well, I'm subtracting these two numbers, vf minus vi. So another way I can say the acceleration is equal to delta v divided by t. If you like the triangle on the velocity problems, you can use that with the acceleration problems as well. The only trick is delta v is what you're going to have in the top of the triangle, so you won't have that final velocity or initial velocity there. So same thing applies though. I would cover up whatever variable I'm asked to find, and then I would do the math as it's given. All right, so looking at practice question number 1 on the acceleration practice. A bicyclist accelerates at 0.89 meters per second squared during 5-second interval. What is the change in speed of the bicyclist and the bicycle? So I'm given the acceleration is 0.89 meters per second. I'm given time is 5 seconds, and my unknown is delta v. So it's not final velocity or initial velocity, it just wants that total value in meters per second. All right, so my parent equation is acceleration is equal to delta v divided by t. So I'm going to rearrange this equation to solve for delta v by multiplying both sides by t. So I would get delta v is equal to acceleration times time. I then take my given values and plug them into the equation. My acceleration excuse me, was 0.89 meters per second squared, and multiply that by 5 seconds. And I end up with 4.45 meters per second as my delta v. All right, practice question number 3, so skipping over a little bit. Once the child in the sample problem reaches the bottom of the hill, she continues sliding along the flat, snow-covered ground until she comes to a stop. If her acceleration during this time is negative 0.392 meters per second squared, how long does it take her to travel from the bottom of the hill to her stopping point? So on this question, we had to look back up to our original example problem, and we find that the initial velocity, which actually is the final velocity on the example problem, but the initial velocity for this problem is 15.5 meters per second. So that's going to be one of our givens, along with our acceleration being negative 0.392 meters per second squared. The final velocity, because we're coming to a stop, is 0 meters per second. And our initial velocity is 15.5 meters per second. And then I want to know time. So I want to know how long it takes before I come to a stop. And seeing that acceleration is negative, we've got a negative acceleration. This kind of indicates to us that we've got something that's slowing down. All right, so my parent equation is acceleration is equal to the final velocity minus initial velocity divided by time. I'm going to convert this to solve for time. So I end up with time is equal to final velocity minus initial velocity divided by acceleration. So plugging in my given values into this equation, time is equal to final velocity minus initial velocity, so 0 minus 15.5 meters per second. So it's going to help take care of this negative that's also on the acceleration. The acceleration 0.392 meters per second squared. I end up with a time of 39.5 seconds. Alright, so walking through one last example problem. This is practice question 5 on the acceleration practice. The gravitational force between Mars and an object near its surface is much lower than the force between an object on Earth's surface and Earth. If the speed of a hammer, when dropped, increases from 0 meters per second to 15 meters per second in 4.04 seconds, what is the acceleration due to the gravitational force on the surface of Mars? So again, I'm going to walk through my givens. My final velocity is 15.0 meters per second. My initial velocity is 0 meters per second. And my time is 4.04 seconds. And my unknown is the acceleration, and that's going to be in meters per second squared. So I'm going to write down my equation that acceleration is equal to final velocity minus initial velocity divided by time. And then I can just start plugging in my values then. So final velocity was 15 meters per second, and I'm subtracting 0 meters per second, so it's still 15 meters per second, and then divided by time. So 15 divided by 4.04 gives me 3.71 meters per second squared. Alright, so now that we've gone through some example problems for velocity and acceleration, it's on to you now to figure out and solve the rest of the questions. I will end up posting or sharing the at least numerical answers. You will need to still show the work on how to get to those answers in order to receive full credit.